After completing horizon interpretation, the horizons can be used to build stratigraphic overlays, velocity models, low-frequency models, and wedge models. There are different approaches to model construction, as you will see in some of our other learning videos. With an Insight base license, Volume Maths is capable of building complex models using simple formulas. If you have access to an Explorationist license, you can use the simple structured model to build these models with an even greater ease. Here I have an interpreted project with 6 horizons. The horizons can be added to a model which defines the stratigraphic structure and stratigraphic rules between the horizons. Click on the Model tab and create a new model. Give it a name such as Horizon Model. The minimum requirement is to choose a dimension of 2A time or TVDSS. This model will be in 2A time. The windowing model itself has no top or bottom. In other words, the top layer of a windowing model extends up indefinitely, and the bottom layer down indefinitely. Therefore, the simplest possible windowing model is a single layer with no horizons covering all data. Add a row. The row can be a constant or an interpreted horizon. I will select the seabed. Add another row, and repeat until all 6 interpreted horizons are selected and assigned. Optionally, conformability can be set between layers. Top-down, flat, horizon, dip field, base up, proportional are all available to set per sequence. It is not necessary for the models that will be generated in this video, and so will be left unchecked. Click on the Process tab and create a new simple structured model process. Give the process a name such as Sequences. Pick the windowing model just created and select the output extents. Each window between horizons is initially assigned an integer value. This output can be used as a stratigraphic sequence overlay when assigned to an appropriate class. Click on the Class tab and create a new custom class called Sequence. Use the banded rainbow blocky colour bar which clearly highlights integer values, and set the range from 0 to 10. Apply a 60% transparency so it can be used as an overlay. Change the volume class and display the volume. By grouping the sequence volume with the original stack, the volume becomes a stratigraphic sequence overlay. A more complex example is the construction of a layered velocity model. I will copy the initial sequence process and give it a new name of velocity layer cake. Changing the formula from simple integers to appropriate interval velocities creates a velocity model. The volume must be assigned as an interval velocity before it can be used for calculations. To finish, let's explore some of the other options. I will create a copy of the velocity layer cake and call it Velocity Complex. The first layer is okay as a constant 1500 meters per second, but the second layer should gradually increase with time. I can adjust the formula to 1300 plus 2A time underscore milliseconds. Selecting the new volume in section view shows the changes. The next 2 layers are complex and vary both laterally and vertically. I could insert the processing velocity volume here to capture this detail. The model dynamically updates with the changes. The fourth layer is a lateral variation and can be represented using a velocity horizon. Again, the model dynamically updates with the changes. The velocity can be overlain on the stack volume using groups. With simple structure models, I've created 3 different models in a very short time that can be used for different purposes. Although the velocity models were fast and easy to build, they will still need validation and QC before using them successfully. If you don't have access to the Explorationist license, check out our volume maths videos to see how similar models can be built only using a base license.
If you have questions or would like to discover more, then visit our website at www.dug.com. And remember, have fun with Insight.